Okay, we just finished up the example with Louisa, and now we're going to be going over an example with a circus. So this is note card 248. It's an angle of elevation example, and it says, at the circus, a person is in the audience at ground level, and it watches the high wire routine. A 5'6" tall acrobat is standing on a platform that is 25 feet off the ground. How far is the audience member from the base of the platform if the angle of elevation from the audience member's line of sight to the top of the acrobat is 27 degrees? Again, the first thing I told you to do in one of the earlier note cards was to read it twice. So I want you to read that again, and I want you to sketch what you think is an appropriate sketch. So pause me and do that. Okay, so here is my rendition. Audience members down here. Here's the stage. They're sitting below. Like here's the audience. Here's the platform. And then it said the person was 5'6", which is 5.5 feet, right? Because there's 12 inches in a foot. So 5.5 feet. The platform was 25 feet. So this whole height is 30.5. And then here's the wire. If you've never seen this, there's a wire, and this person goes and walks across the wire and does some cool things. This audience member has an angle of elevation. So this wire is horizontal. So here's an angle of elevation, and I think it said 37. Let me just look again. 27 degrees. Okay, 27 degrees. So this is 27 degrees. Because it said they have an angle of elevation to the top of the acrobat is 27 degrees. And it says, how far is the audience member from the base of the platform? So this is the base of the platform, right here. This is the base of the platform. And so this is X. So I have a right triangle. I've got, oh, this was supposed to be to the top of the person's head. Man. Okay. Okay, to the top of the person's head. Okay, and this is just the wire I wanted to show you. That's not the horizontal that it's coming from. The horizontal that it's coming from is right here, this base. So this was 27 degrees. All right, so I've got adjacent is X. I've got opposite is 30.5. So that's tangent. Tangent of 27 degrees equals opposite over adjacent. Cross multiply. Divide by tan 27. You'll get 58.9 feet. Okay, so I'll plop those images in here, and that really should say 58.9 feet. Let me fix that. There we go. So it's really right around 59 feet that the audience member is the length, the distance from the audience member to the base of the platform. Now here's just another way to think about it. This is just where I got this information from. So it has all the same things, but I just wanted you to see that. All right, so if you haven't yet, pause me and finish up note card 248. All right, note card 249, angle of elevation again. At a diving competition, a 6-foot tall diver stands at the top of a 32-foot platform. The front edge of the platform projects 5 feet beyond at the ends of the pool. The pool itself is 50 feet in length. A camera is set up at the opposite end of the pool, even with the pool's edge. If the camera is angled so that its line of sight extends to the top of the diver's head, what is the camera's angle of elevation of the nearest degree? See, I think the hardest thing with problems like this is understanding what it's asking and drawing the picture. Because the trig you're probably doing well on. So pause me, write this down, draw a picture, and then unpause me and see if you got it right. How'd you do? If you've ever seen diving, you realize, there's a diving board, or even seen a pool with a diving board. It said it extends out 5 feet. I think that's what it said. Now I need to double check. Yeah, it projects 5 feet beyond the ends of the pool. right into the platform, projects 5 feet beyond. Yeah. Okay. So I'm going to create right here this. So I'm really looking at this right triangle. Okay. It wants this angle right here of elevation. This is a 90-degree angle. This whole height is 38 because 32 plus 6, so that person was 6 feet tall. And this is actually only 45 because we have to take away the 5 feet from the platform. All right, so once again, I have TOA, opposite and adjacent. So tangent of x equals 38 over 45. X equals tan inverse of 38 over 45. And then, right, we type tan inverse in of 38 over 45, and we get 40.2. So that angle is 40.2. All right, so I've got the picture here and the answer here. That was note card 249, so make sure you pause and finish that up. The next thing I want to talk about is there are some problems that have two angles of elevation or depression, and they help you determine the distance between two objects. And so you're going to see that in an example that we'll do here in a minute. And this one too, it's just not a note card. So this one, there's a building, there's a flag. We're given an angle of elevation of 57.3 degrees here and 64.6 degrees here. And let's see, I think it's given that tangent of 57.3 equals pi over 20. And then we can figure out that y is 31.15. So we get that. And then we can do the big triangle here and say tangent of 64.6 degrees equals all of z over 20 and figure out all of z. So you can get all of z is 42.12. All of y is 31.15, and to get x, you would just subtract the 2. So that's like an example without the word problem, just the image and the word. So you can see that you could find the height of the flagpole if all you knew were these two angles of elevation and this one length. All right, so let's actually do this. Let's put this in practice. This is note card 250. This is an example with two angles of depression given. All right, so go ahead and pause me and write this down and draw a picture. All right, so here's my picture so far. Here's the cruise ship. Here's Vernon. He's 154 meters above sea level. Here's the sea. Here's Dolphin 1 and Dolphin 2. And it said that the angle of depression to the dolphin. So I need to draw my horizontal line, which is parallel with the water. And angles of depression come from a horizontal above. And I think it said 35 and 36. Let me just double check. Yeah, 35 and 36 degrees. Okay. So angle of depression, here's the first one. It would be the smaller of the two angles. That would be 35 degrees. And then this one would be 36 degrees. Now I exaggerated. Now that 36 goes to this whole angle. This whole angle is 36. Let me maybe do a different color. So that whole angle is 36. And I know that's hard for you to read. Let's see. I think that helps. Okay, now it wants the distance between the two dolphins. So I want this distance right here. Now, I can only use trig with right triangles. Here's my right triangle. So when we're in Math 3, we'll be able to do this using non-right triangle trig with this obtuse triangle here, but right now we can't do that. Now, what can I infer? Well, I know that these are parallel lines. This line is parallel to that line. So this blue angle is the same as this angle. Those are alternate interior angles. So this is also 36 degrees. So this triangle that I'm getting ready to highlight in yellow we can do some information. And then the big triangle, get a different, oh, I've got a different color right here. Hold on a minute. I had to pause and find my orange highlighter. So, okay, this is 35 degrees, and so this is 35 degrees. We have the yellow little triangle, and then I'm going to do this. We have the orange big triangle. So what we're going to be able to do, those are both right triangles, so we can use trig, and we can find this bottom distance on the yellow. We can find this bottom distance on the orange and subtract to get x. Okay, we have to use the yellow right triangle and the orange right triangle because that's all we can do for trig. So again, we're going to find the yellow distance here. We're going to find the orange distance here, and to get the distance between the dolphins, we're just going to subtract. So I'm going to do yellow here. All right, so if I look, I know that this is 154, and I'm going to call this yellow distance down here y. Highlight it yellow. Okay. So we're trying to find this side, that is the adjacent to this angle, and this is opposite. So a lot of these are tangents, so we're going to use TOA. Tangent of 36 degrees equals opposite over adjacent, TOA, cross multiply. Divide by tan 36. And I get that y distance is 211.96. That's the yellow distance here. That's this yellow distance. Now I'm going to do the large orange distance. That long distance, which is y plus x, but just for ease, I'm going to call that long distance z. Okay, because I already had an x here, so all right. So the setup, looking at just the orange triangle, again, we're trying to find z. Let me highlight the z, which is the adjacent. Okay, that's adjacent. And we know the opposite. So TOA, tan of 35 degrees equals opposite 154 over z. Cross multiply. Divide by tan 35. And in case you didn't know this trick, it's basically the same thing we just typed in. We just got to change that to a 5. So I'm hit second enter. And it brings what we just typed in back up. I'm just going to scroll over and put a 5 there. I get 219.93. So what is the distance between the dolphins? We would simply subtract these two. Ah. And so the distance between the dolphins is about 7.9. I think this was in meters, so about 8 meters. All right, so I put the images back on the slide so you can see them. I know it's a lot going on. You might want to rewind and watch that again, but go ahead and pause and finish up note card 250. This image is just another way to think about it. They put the cruise ship over here. It's the same work, but some of you may find usefulness out of these to see how they got to the answer, but it was 8 meters. Fun, fun. Finish up note card to 250.